Hi, welcome to lesson 13, data types. On conversions. We need to think like computers. While going for my bicycle ride, my thoughts started wandering. I wondered, how does a computer convert from a decimal to a binary, to octal, or even to hexadecimal numbering system? I'm sure you guys have had the same thoughts, maybe while having a braai, a swim, or even while in the gym. Well, in this lesson we're going to see how one can convert from one numbering system to the next. We'll look at converting from a decimal to binary, to octal and hexadecimal numbering systems. Now, to do this we need to think like a computer. It may sound complex, but believe me, it's not. After all, computers do this, just thinking about ones and zeros. So how difficult can it really be? Let's say we have a decimal value of 3,899. Now we want to convert this value to the following. Let's say we want to convert it to an hexadecimal number, an octal number, or a binary number. How would we go about this? Now, the best is to think like a computer. The computer thinks in zeros and ones, either 5 volt or 0 volt and so on. If you recall in lesson 9, counting from 0 to 31 on one hand, you'll recall the computer system is a binary system. So we'll start over there. Now the binary number can be written as a times 2 to the power of 0, because the binary system is a base is 2, plus b times 2 to the power of 1, plus c times 2 to the power of 2, and so on until n times 2 to the power of n. Okay, so now for easy reference we write the base 2 to the n below. And what we'll do is we'll stop one power above our value of 3,899. What I'm referring here is, if you look at the base of 2 to the power of 0, 1, 2, and so on, it doubles. So it goes 1, 2, 4, 8, 16, 32, 64, 128. So you double every time. 256 plus 256 is 512. If you double 512, you add another, it goes to 1,024, 2,048, 4,096, and so on. So that's the binary system, the base 2. Okay. What I'll do is I'll swap them around. So the least significant bit is to the right hand, like you write any number system. So I've just turned it around here, as you can see, so that the smallest bit is that side, and as we move this way it gets bigger and larger, in other words. Okay, so the rule is we take the highest into the 2 that fits in our value. If it doesn't fit, we mark that value with a 0. Now I'm going to start, I could have had a 0 here, but you can see the highest bit that fits our value of 3,899, 4,000 is too big, so it doesn't fit into that one there, or you understand? So the highest one that fits into 3,899 is 2,048. So we mark it as 1. What we do then is we take our value and we minus the 2,048, which gives us a remainder of 1,851. So it's important we mark that bit there in our binary system with a 1, and then we minus 2,048 from our value, our decimal value that we want, which is 3,899. Okay, so next step. Now we got 1,800, which we carried over, 1,851, and we use again our rule take the highest 2 to the power that fits into a value, otherwise mark it 0. Now we know that 1024 fits into 1851, so we mark it with 1, and again we minus it from our value. That leaves us with a remainder of 827. So we move to the next one. So we carry over now 827, and 827 fits into 512, or 512 fits into 827 rather, sorry. So we mark it as 1, and then we say 827 minus 512, and that gives you a remainder of 315. So move to the next one. We carry over 315, and we say 256, which is our next binary power here, fits into 315. So 315 minus 256 gives you a remainder of 59. So we mark the 1 there, and we got 59 left. Now we carry the 59 over, and now see what happens here. 59, 128, our next binary power there, does not fit in 59. So we mark it with a 0. We move to the next one. 64, well, 59 doesn't fit. 64 doesn't fit into 59. So we mark it with a 0 again. Then we see that 32 does fit into 59, so we mark that one with a 1. And yeah, we actually using the second part of this rule. Take the highest n that fits into our value, else mark as 0. So we mark these two as 0, and that one is 1, because 32 fits into 59. So you mark it with 1, and then 59 minus 32, and that gives you 27. So we move to the next one. We carried over the 27, and then we apply the rule again, the highest bit. And the highest bit here, we see that 16 does fit into 27, so we mark the power, the bit that indicates a maximum of 16 with 1, and that gives us 11. And we carry on, and we carried over 11, and we see that 8 fits into 11, so we mark it, and 11 minus 8 gives you 3. And we go to the next one, and yeah, again we got a situation where we'll see that 4 does not fit into 3. 4, in other words, our 4 is greater than our carried over, so we make it a 0. And then we go to the next one, we see that 2 does fit into 3, so we mark it with a 1. And then 3 minus 2 gives me a 1. Okay, and then we move to the next one, and we take the 1 that was carried over, and the last one we see that 1 fits into 1, so 1 minus 1. And when we reached at the end, we got nothing left, it's 0. We've come to the end of our binary number. And as you can see, so we write out the binary number, so 3899. Each binary equivalent is 1111 00 11 1011. So 3899, and there you see its binary equivalent. Okay, I'm going to show you a little app or Java application, which I'm going to print 3899 to binary, just to show you how simple it is to do programmatically, which we just did mentally or manually. So I've got a public class called decimal to binary, and in my main method, public static void main string args and so on, all I did is I'm outputting my wrapper integer class has got a method to binary string, so it will output the binary string, and I've put in the integer literal 3899. So I'm telling the static method in my wrapper class, integers wrapper class method called toBinaryString, and it's going to convert it to the binary equivalent. So I'm just going to compile this since I've saved it already. I can compile it in memory. So I'm going to say Java, and the name is decimal to binary.java, and if everything goes well, and there it is, and there is the result. So I'm just going to minimize this one and bring that one there, and you can see the result there is 4 ones, then 100, sorry, 1 2 3 4 ones, 1 2 3 4 ones, 2 zeros, then 3 ones, and a 0 and double 1. So there you can see it's the same. 4 ones, 2 zeros, then 3 ones, 0 double 1. Okay, so that is just done programmatically showing how you go from a decimal to a binary. And that is step 1. We converted a decimal number to a binary first, and then we'll move on from there. Okay, now that we did step 1 where we converted the decimal to our binary equivalent, now we're going to do step 2. Now it's easy to convert either to an octal or a hexadecimal. I'm going to start with the octal first. There's no particular reason for this. I just decided to do the octal first. Okay, we could have done the hexadecimal as well. Okay, so let's go. So counting octal, you go 0, because octal, remember, you count from 0 to 7, and then it's 1 0 1 1 1 2 and so on. So 8 in octal is 1 0. Remember, that is not a 10. 8 is 1 0 in octal, because octal only consists of a base of 8, where decimal is a base of 10. Okay, so you see over there. Now we can represent the 0 to 7 in 3 bits in a binary format, because if you recall, the binary format of 0 0 0, the base 2 is 0, and then 1 1 1 to the base 2 is 7, because it's 1, and that's a 2, and that's a 4, and if you add them gives you 7, which fits exactly in our octal system. If you can see, this is our first power, and that starts our second power base. So this would be base 0, base 1, and so on. Not base, a power of 0, power of 1, and so on. So that's how I guess a computer does it, because the computer thinks in zeros and 1. So yeah, I've just shown the powers, power of 1, the octal, the binary system 1, 2, and 4, which I'm showing over here as well. So in the binary format, you would write the octal like this. The 0 is 3 zeros, 1, 2, 3, 4, 5, 6, and so on. And obviously the 7, which I'm missing here, would be 111 over there. Okay, so now we just take our binary number which we had before, and we group it in bits of 3. Now if you remember our binary number when we converted 3899 previously in step 1, this was our binary system. So we group it in groups of 3 from left to right. So it is 0 1 1 1, and then that is the 3, you see. And then we take the next one there, which the next 3, and there's the next 3, and there's the next 3, and the next 3. Now it's easy to see the values. So we know this one is 1 plus 2 is 3, so we write 3. We know 111 is 7 in binary system, so we write the 7. We know this is a 4 because it's 1, 2, 4, so we write the 4, and we know this is a 7. So the octal is 7473. So yeah, we've converted 3899, the decimal, each octal number, or in octal format, it is 7473. Okay, let's see how we would do this with a small app in Java, which is much simpler. So yeah, I've got a class called Decimal.to.Octal, and in my main method, all I'm doing is I'm calling the static toOctalString method of my wrapper integer class, my primitive, my wrapper that wraps in a primitive int called integer, and it takes I'm putting in a integer literal 3899, and it will return a string representing it in the octal form. So let's go and compile and run it, and I'm going to just compile and run in memory. I'm going to say Java, and it's decimal to octal.java. And as you can see, it's very simple when you're doing it in Java, because the method is there, so it's doing it for us. And I'm just going to show you there. There is the value 3899, and we worked it out to 7473, and there it is 7473. So the octal value is 7473. Now we're going to look at converting to an hexadecimal number. Okay. Hexadecimal number, as we know, is from 0 to F. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, and F. Okay. Now we can represent the 0 to F in 4 bits in the binary format. And that's how I guess the computer does it. So if you look here, I've got the binary and the hexadecimal and its binary equivalent. So 0 will be in the binary, it will be 4 zeros. So 1 will be 0, 0, 1. 2 will be 0, 0, 1, 0. 3, 0, 0, 1, 1. 4, 0, 1, 0, 0. And you can see why, because that power that you count, it's 1, 2, 4, 8. And the 1 is indicating on the power of 2, because power 0, 1, and 2, that gives you 4. Okay, and you go on. 5 is 0, 1, 0, 1. 6 is 0, 1, 1, 0. 7 is 0, 1, 1. 8, as you can see, is 1 and 3 zeros, because it's the power of that would be 1, 2, 4, 8. And 9 is 1, 0, 0, 1. And then your A is 1, 0, 1, 0. B is 1, 0, 1, 1. C is 1, 1, 0, 0. D is 1, 1, 0, 1. E is 1, 1, 0. And F, obviously, 1, 1, 1, which represents 16 in our decimal format. Okay, so here we got, I'm showing you an example of all the numbers of the hexadecimal in the binary format. So I'm representing them with 4 bits, in other words, or 4 places, if you could call it, of your binary number. Okay, so in the next, now we take our binary number and group it in 4 bits. So I take my binary number, that 3899, which we converted earlier on to a binary, and here it is, and we group them in 4s. So take the first 4, the second 4, and the third 4, and then we know that this one is 1, 0, 1, 1 is a B. If you go before, you'd see there 1, 0, 1, 1 is a B. Then this one is 3, obviously, because it's 1 plus 2 is 3. And we've grouped those 4 bits, and here's the... Okay, so once we got that, we've actually converted the number to hexadecimal, F3B. So 3899 and in a hexadecimal format is F3B, and that is how we convert it to hexadecimal. Okay, here we're going to do the same thing but using Java code to show you how easily it can be done. So I've got a class here which I call decimal.to.hexadecimal, and in my main method I'm printing out, and what I'm doing is I'm just using, as the Octal in a previous example, I'm using the integer class, one of its methods, which is a to-hex string. So it converts the integer literal that I assigned as a parameter here, it converts it to its hexadecimal, and to a string that represents hexadecimal, and then it prints it out. We're printing that value out. So let's look at what the end result is. So I'm just going to go and compile it into memory, and compile and run it, in other words, Java. And I'm going to say main, not main, sorry, this is decimal to hexadecimal, and as you can see there, 3899 to hex format is F3B, and yeah, it's the same result as we had when we did it manually. Now let's say we want to work in the opposite direction. Say we got an octal number and we want to know what the decimal number is. Okay, so here I've got an example. Say we have an octal number of 725. Can anyone tell me what 725 is in decimal format without using a calculator or something? Okay, so and say we have an octal number of 725 and we want to convert it with a decimal equivalent. We just do the same as before. We just convert from an octal to a binary equivalent, and then from the binary to the decimal format. So let's go ahead and do that. So like before, we know that each octal can be expressed in 3 binary digits, as from 0, which would be 000, to 7, which would be 111. So it's easy to match, because we just write down 7 to 5 that we want to convert, and we know the 5 is 101. We know the 2 is 010, and we know the 7 is 111. So already we've converted it to our binary number. Very, very easy and quick. And now we want to go from this binary to the decimal, and I'm sure you guys have figured that one out already. So we just go to the next step, and we write the powers of our binary number on the top again, from least significant to the most significant, and we put our binary number there, as you can see over there. And then all we do is we add all the values that have got a 1. Obviously we don't need to add the zeros, because it would make no difference. So it's 256 plus 128 plus 64 plus 16 plus 4 plus 1 is 469. So the octal value 725 in decimal format is 469. Okay, yeah, I'm showing you how to do it in code in Java. It's very simple. I've got a class called Octal.toDecimal here, and in my main method, all I do is I'm printing out the octal value, and it will print it out in its decimal format, because if you recall on my previous videos, you can if you start with a 0, an integer, int value, or an integer literal with a 0, it is an integer literal of the octal type. So I'm starting with a 0, 7 to 5. The 0 tells me it's an octal. And if you haven't seen, just go look at my previous 2 videos, the one on integer, the primitive int type, or the primitive long type. I believe I mentioned it there. And that's it. And it will then give me the actual decimal value. So let's try that. I'm going to compile it and run it quickly. So it's Java, and it's Octal to decimal and .java, and there it is. And you see the octal value 0725. Its decimal equivalent is 469. Okay, let's look at the last one that's left, converting from a hexadecimal number to a decimal number. Now, to do that, as you must probably realize by now, we do the same as we did before. So we have a hexadecimal number of 2CA. It's very difficult to work out what that number is on the decimal format that us humans use. So what we want to do is we want to convert it to the decimal equivalent. And to do that, as I said from the beginning, the easiest way is to think like a computer. So we convert it from a hexadecimal to a binary format, and then from the binary format to the decimal format. Okay, there's other ways, so this is just an easy way of remembering and doing it. So yeah, on step 1, we convert to a binary number, and as above, each hexadecimal can be expressed in 4 binary digits, and we did that before. So we know a hexadecimal number is 16. It goes from 0 to F, and the 0 we've got here represented as 4 zeros, and the F, or this. Okay, so all we do is we take each one of the hexadecimal digits, the 2CA, and each one we convert into its binary equivalent. And the A, as you can see, it's 1010. The C is 1100, and the 2 is 0010. And you can go back and look at the previous the video just that I showed the whole table just before. So you'd get this, but you can work it out. Then you got the binary here, and the next step is to get it to the decimal. So we go to the decimal here. Again, we take the binary and we just write out its powers like that: 1, 2, 4, 8, 16, 32, and so on. Like I've exhausted the explanation on this before. And then we map the binary to it, and then all the ones we add them together. So it's 512 plus 128 plus 64 plus the 8 plus the 2. If we add them all together, it gives us 714. So 2CA, the hex number 2CA, actually represents 714 in decimal format. And once again, I'm showing it in code, and it's a way of proving our results, I suppose. I'm showing it in code, and I've got a class here called Hexadecimal, and in my main method I'm printing out, and it's as easy as just adding the integer literal of hexadecimal format, because we know when we start with a 0x, these two over here, 0x, it represents a hexadecimal format of your integer literal. And then I'm just going to output it. So let's just compile and run this. So I'm going to say Java. I'm just going to move it like that so you can see there. Java and the name Hexadecimal. Hexadecimal dot Java, and if I spelled it right, it seems like it. No, my D should be capital there. Let's just change that to a capital, and let's see, everything goes well, and you can see that the hexadecimal 2CA, its decimal value is 714. We've come to the end of lesson 13 on data type conversions. Yeah, we looked at how to think like a computer when converting from the different numbering systems, namely from the decimal to the binary and then to the octal and the hexadecimal formats. We also looked at the reverse, in other words, from octal to binary and then the decimal. This is simplified if we think like a computer, as a computer uses the binary system. We also saw some examples on how simple it is to do it in Java code by merely using the integer class methods or using the built-in integer literals of the specific format type, like the binary use 0b, the octal starts with the 0, and the hexadecimal you start with the 0x. Okay, I hope that you learned something and no longer will wonder about this when you're swimming, fishing and so on, you know. Before we go, please don't forget to like my video, press the subscribe button as well as the notify button so that you'll get notified when I release more videos. I've also got a Facebook page related to this channel. You're welcome to visit. Any comments are welcome, and have a great time. Until we meet again, I wish you well. Ciao.